Hello everyone, welcome back to the Model Context Protocol video series. So over the last few videos, we have been exploring both Model Context Protocol MCP Server and MCP Client. And over the last couple videos, in fact, we have been exploring how to use an LLM agent to connect to the MCP server via an MCP client, to in turn connect to the application layer. The use case that we have been exploring, the application layer is a MSSQL database instance, um, and we have been able to demonstrate how to use this LLM agent to answer natural language user prompts based off data in the database using MCP server tools, prompts, resources. The other thing that we have explored is the challenge. Is so when using LLMs with MCP. I should clarify that. So what I mean by this is, while MCPs were developed keeping LLMs in mind, LLMs, at least the LLM SDKs that we have available right now on the internet, they are not yet configured to use MCP completely or directly. And again, what I mean to say by this is, LLMs inherently do not understand what MCP server prompts, tools, resources are from the perspective of an MCP, right? LLMs only understand function calling. It only understands the concept of having tools, a certain set of tools, and based on certain user prompts, it can call a particular tool. And so what we do when we are combining the MCP with LLM, when we're using LLM agent, is we basically have this side step where, for example, with our mcp-use example, what we are doing is we're using LangChain adapter to convert any MCP server tools, resources, and prompts into LLM LangChain tools, which are then fed into the LLM agent as LLM tools, which can be used as function calling. Now, what this means is the LLM loses any awareness about the separation of natures of these different features. For it, all of the MCP server prompts, resources, tools are all equivalently function calls. But that is not the case. When a resource is designed on the MCP server side, it is designed keeping in mind that it is to be used as a data source to provide extra context to the client when it is coming up with user response. When a prompt is created on the MCP server, it is created in mind, keeping in mind that it is to be used to provide more guidance to the MCP client when it is trying to come up with a response, working on certain workflow in response to your user prompt. So we needed to figure out a way to preserve this, to preserve this understanding when recreating this MCP server tools, prompts, resources as LLM tools. So the solution that I thought of for now was, basically during the process of conversion of the prompts, resources, tools into the LLM tools, append a tag prompts underscore tools underscore resources underscore, depending on whether it was converted from MCP server prompt, resource, and tool. And then in the system prompt of the agent, define what a resource, prompt, and tool is from the perspective of an MCP. So this gives the LLM agent an idea that not only it has a set of tools, but it has a set of tools with three distinct type of tools, prompts, resources, and tools. How it can identify these three unique types of tools is by looking at the prefix. If it's a prompt, it's of type prompt. If it's resources, it's of type resource. If it's tools, it's of type tool. And we, in the system prompt, I'll show it in the code. We are feeding in information about like resources, prompts, tools from the perspective of an MCP server, so that the LLM is aware how to use them. And implementing this has shown some really positive results, and so that's what we'll be exploring in this A/B test. We we'll be using agent A, which is the control agent, which has access to the MCP server. The tool executes SQL query, then it has access to the two resources, the static and the template resource, the schema resource, and then it has access to the prompt, right? Excuse me. For agent B, it is exactly same thing. It has access to all the same things, except the tools that are created from these MCP components have the prefixes resources, prompts, tools, and the LLM agent is aware that it has the tool calls which have three different distinct categories. So yeah, let's go forward with the A/B test. Before that, let me quickly walk you through the code. So in the main, and just like before any of the A/B tests before, we are starting at the main. There is a framework, like we are creating a framework instance, and then we have this function run semantic A/B test. And if we check that semantic A/B test function, we will see that ultimately it does that test single case function with either A or B case. So here test single case with either test case A generic or B semantic. And then if we check the test single case function, we'll see that for A generic it calls the create approach aiagent, and for B semantic it calls the create approach bagent. And if you look at both the agents, we'll see they're essentially identical, with the only difference being the tools, how like what the tool names essentially that are being included in the LLM, right? So for agent A, the tools are directly, like we have the tools created, the MCP server static resource tools and prompts are created by default from LangChain adapter. We have our custom code to create the template resources, convert the template resources into LangChain tools, and feed all of this into a single all tools list, which is then finally fed into the agent so that it has access to all these tools. And then we have agent B, where we are creating the all tools list using this create semantic tools function, which is basically the custom function, which does nothing other than just add that tag in front of each function based on whether it's being created from a resource, tool, or prompt, right? And then if we, now this prompt is an important part. Now if we look at the prompt here, we see that we are defining what the resources, tools, and prompt tool calls are. So we say resources are file like data sources for quick reference, tools are functions that execute database operations, and then prompts are pre-written templates that provide systematic guidance for complicated tasks, right? And then we tell it that the recommended pattern is like usually you should, for complex tasks, you should always run any prompt, then the corresponding resources, and then the corresponding tools. And for simple lookups, you can just use the resources directly. And for absolute straightforward operations, you can probably even directly use the tools. But always for complicated tasks, always use the prompts first, right? And that's basically it. The other details are all identical. So again, like verbose is true, intermediate steps are true. We are using max iteration 15. And then we have increased the max execution time to 1.5 minutes from 1 minute that we had been following in the previous A/B tests. So yeah, let's quickly run the A/B test. Now, just like before, I'll be fast forwarding the A/B test execution time, and once it is done, we'll again begin or continue rather from where we left. So let me start the testing. UV run Python A/B tests semantic naming A/B test framework.py, and then yeah. Perfect. Okay, our A/B test has finished running now, and what we'll do is first, just like before, we'll generate HTML reports of the .txt and .json reports generated, so we can have an easier time going through the results obtained. So let's do just that. Let me actually clear the screen first, and then here we run Python report gen, convert to report, and then let's do semantic. So we have that one done, and then the other one is we run Python report gen Generate semantic report on this, and then we have the JSON file, which is semantic naming AB results. So we have the JSON and the .txt converted to their HTML versions. So let's quickly try and open them up in Chrome. Yeah. So first, very quickly, you can probably see it right over here as well. You can see that for agent B, they're semantically named. That is, the tool is named as tools underscore resource has resources underscore, and you will see prompts will have prompts underscore. Now the very first thing you will see that other than the first one, which is a really simple query, it looks like test 2. Notice that prompts has been invoked, test 3 prompts has been invoked, test 4 prompts has been invoked, test 5 prompts has been invoked, test 6 prompts has been invoked. For all the cases, prompts has been first invoked, and then we can see this general pattern. Like we can see it following the specific pattern. It first invokes the prompts, then invokes resources, and then finally it invokes tool. Again, for the next one, prompts, resources, and then finally tools. Then third one, prompts, all the resources, and then it goes through a series of tool execution. So we have been able now, after passing in context about, after giving the LLM this understanding that it has 3 different specific types, 3 distinct types of tool calls available, and how each distinct type of tool call is to be used, like one as a resource, one as a prompt, and one as a like a default tool or classic tool. We have actually been able to make it work how we were expecting it to work, exactly how we were expecting it to work. First, it executes the prompts, or rather it goes to the prompts to see how it is supposed to do something. Then it goes to a series of resource calls to get details about the tables in the database for additional context, and then it starts executing its tools to actually get results. So this at a quick glance is already some really good results, at least something that we have been working towards. And now if you look at the time, we see that for test 1 this took less time, for test 2 this actually took more time, for test 3 it took much less time, for test 4 it took slightly more, for test 5 it took way less, and in fact test 5 failed for agent A, was not able to finish agent A. Agent B was able to get some data. Now it is still you would still have to really go through it to see if it's the expected data or not, but it looks sensible, which agent A was not even able to produce. And then for the 6th test case, it looks like aiagent B has been quicker. I think both of them get the correct results. At least it looks identical to what we have here, but this one takes less time, around 5-6 around 5-6 seconds, I would say. Again, this is just one test run, as I have been saying again and again. Whenever we do an A/B test, it is very important to do multiple test runs to get a complete picture. This just gives a very brief snapshot of the entire behavioral pattern of these agents, right? So this is just one example, so yeah, we'll keep doing it, but at my end I have done multiple results, or rather multiple tests. And from this, one thing that there have been two things that I have been able to determine. One is usually agent, or not usually agent B. Agent B definitely follows this pattern where it first hits the prompt, unless it's the first test run, which is extremely simple. It first hits the prompts, then hits the series of resource calls, and then hits the tool calls. This has been established. And next, usually across multiple test runs, I have seen that usually the agent B has a tendency to take lesser time than agent A. Now this observation I will again clearly demonstrate in the next video. So coming to that, And then quickly, just before talking about the next video, again, like we have this as well, which like has all the log details and details. I won't really go through it in right now, but the idea is again just to collaborate what we see here with the detailed information here, right? So coming back to the next video, so now that we have a custom MCP server, or rather MSSQL MCP server with a prompt, resource and tool, and we have been able to create an LLM agent in a manner such that it has an idea that it not only has tool calls, but these tool calls are of 3 distinct specific types, and we have been able to communicate this idea with the LLM. What we'll do is now compare our MCP server, MSSQL MCP server, with an industry standard MSSQL MCP server. The example we will be using as the industry standard will be a Microsoft designed MCP server for their MSSQL database. Now, if you look at the GitHub repo, and I'll try to attach a link in the description in the next video, not in this one, you will see that Microsoft has 2 versions. One is a .NET version and one is a Node version. I believe, I know we are using the .NET version here. And I very sure that both of the MCP servers have the same set of tools. Exact same, I think 6 tools they have in total, both of them. Or rather, each of them have the same exact same 6 tools. So yeah. So the idea is when we compare a custom MCP server with the like the industry standard MSSQL MCP server, not only are we going to see how, or rather, that was phrased wrong. What we are going to check is how MCP server behaves differently when it has access to resources, tools, prompts, rather than in comparison to an MCP server which has access to only tools. Now, of course, we'll also be interested in seeing if the custom MCP server, which has access to this resources, prompts, and tools, and not just tools, all 3 of them, performs better in comparison to the industry standard MCP server, which has access to only tools. The challenge with that is we still need to set up a guideline to determine how to define if one MCP server is better than another. So for now, I'll be following just 2 metrics. One will be the time consumed by the agents, and the other will be how successful the agents have been in returning back the results. But again, this is for the next video. We'll talk about it in the next video. I feel like this is a good place to end. Cheers. Talk to you guys later. Bye.